Hi there, and welcome back to another Papetti Math YouTube video tutorial, where today I am going to be teaching you, yes you, Algebra 1. And in this video, we are going to be combining all of the information that we have learned in this chapter on factoring, and we are going to be choosing the best method to factor. So each lesson in this unit is organized by a different method of factoring. However, in this lesson, you must decide which of the factoring methods you have learned thus far would be the best way to factor each polynomial. So, starting with exercise number 1, factor each of the polynomials completely. So the first thing that we should always do is look for a GCF. And do we have a GCF in part A? And the answer is yes. Our GCF is going to be 50 because each of these terms is divisible by 50. So 50, when we divide each of these by 50, we're going to get 4x squared minus 1. Now we look back inside those parentheses and we see, is there a GCF? No, there's not. Now, is this a difference of two perfect squares? And the answer is yes, it is a difference of two perfect squares. So we bring down our 50, we open up two sets of parentheses, and we put the square root of 4x squared in the front of each parenthesis. So that's 2x times 2x is 4x squared. And 1 times 1 will give you 1. Remember, when we factor a difference of two perfect squares, we separate these with a plus and a minus. This brings us to part B. Is there a GCF in part B? And the answer once again is yes, there is. And the GCF is not only 7, but you should also notice that they all have at least one x in common. So 7x is your GCF. And we're going to divide each of these terms by 7x, that means. And we will be left with x squared plus 2x plus 1. Now after we divide and we're left with x squared plus 2x plus 1, there is no GCF inside those parentheses. It's definitely not a difference of two perfect squares. So we look if this is able to be factored using the trinomial method of factoring we learned. Are there two numbers that multiply to get 1 and those same two numbers add to get 2? And yes, there are. What two numbers would multiply to give you 1 and add to give you 2? Well, let's start off each parenthesis with x, because x times x is x squared, and 1 times 1 is 1. 1 plus 1 is 2. So we have 7x times x plus 1 times x plus 1 is the factorization of this whole trinomial up here. In part C, we do not have a GCF, right? Yes, we do not have a GCF. So now we think, is it a difference of two perfect squares? No, it's not a difference of two things. It's three things already, so it's not a difference of two perfect squares. Can we factor this using the normal method of factoring where we look for no, because a is greater than 1. So since a is greater than 1, we're going to be using that AC method where we multiply a times c and get negative 6, and our b term is negative 1. So what two numbers are going to multiply to negative 6 and combine to get negative 1? That's going to be negative 3 and positive 2. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Now that we know that, we're going to start each parenthesis off with a 2x in this case. We're going to know our factors are negative 3 and positive 2. And our final step is to divide one of these sets of parentheses by our a term, which is 2. Which one of these parentheses is divisible by 2? That second one is. So I'll just bring down my 2x minus 3. And I'll have 2x divided by 2 is x, and 2 divided by 2 is 1. So my final factorization there is 2x minus 3 times x plus 1. Let's go to part D now. In part D, we have 4x squared minus 20x plus 25. I don't see a GCF. So I'm going to be using my AC method here because a is greater than 1. So when I multiply a times c, I'm going to get 100. And my b term is negative 20. So again, I need to multiply to 100 and add to negative 20. So this one is going to be negative 10 times negative 10. So I'm going to go ahead and open up two parentheses, start each one off with 4x and 4x because that is my a term now. I know that my factors are going to be negative 10 and negative 10. And my last step is to divide one of these parentheses by 4. But neither of these is divisible by 4, so we think of two numbers that multiply to 4, and that's 2 and 2. And each of these parentheses is divisible by 2, so I'm going to divide each by 2, and that's the same as dividing 1 by 4. So I'll be left with 2x minus 5 and 2x minus 5. And finally, when I have the same exact thing in each parenthesis, I could rewrite that even simpler as 2x minus 5 squared. This brings us to part E, where it says 4x squared minus 49. And when we have 4x squared minus 49, we do not have a GCF. Is it a difference of two perfect squares? Yes, it is a difference, and both of these are perfect squares. So we're going to open up two parentheses, put the square root of 4x squared in the front of each parenthesis, so we're going to have 2x and 2x. The square root of 49 in the back of each parenthesis, 7 and 7, and we separate these with a plus and a minus. That is our factorized 4x squared minus 49. In part F, we have 12x squared minus 44x plus 7. We do not have a GCF, but we are going to have to use that AC method because a is greater than 1. So we're going to have 12 times 7 gives us 84, and we have to have a b term of negative 44. So what two numbers will multiply to 84 and add to get negative 44? If you need more time, pause the video, please. And those two numbers you should have thought of were negative 42 times negative 2. Negative 42 times negative 2 is positive 84, and negative 42 minus 2 is negative 44. So we're ready to begin factoring. We'll start off each parenthesis with a 12x, because that's our a term. And we're going to put in negative 42 and negative 2. And are either of these parentheses divisible by 12? No. So we have to divide one of them by something that's divisible by 12. 12 is special because the other ones were just one possibility. This one we could do 4 and 3 or 6 and 2. So is one of these divisible by 4 and one divisible by 3? This one's divisible by 3, but this one's not divisible by 4, so we're going to have to be using 6 and 2. This set is divisible by 6, and while the second set is divisible by 2. So if we divide one by 6 and the other by 2, that's the same thing as dividing the whole thing by 12. 12x divided by 6 gives you 2x. Negative 42 divided by 6 gives you negative 7. 12x divided by 2 is 6x. Negative 2 divided by 2 is negative 1. So there we have 2x minus 7 times 6x minus 1 as our final factorization. And now it brings us to our last three here, where we have 2x squared plus 20x plus 48. And again, we look for a GCF. We do have one. It's 2. So we're going to divide all of these terms by 2, and we'll be left with x squared plus 20x divided by 2 is 10x. 48 divided by 2 is 24. And now we look inside these parentheses. I don't see a GCF. Definitely not a difference of perfect squares. So I use my method of factoring when a is equal to 1, which is I just look for two numbers that multiply to 24, and those same two numbers add to 10. I start off my parentheses with an x and x because x times x gives me this x squared here. And I should have thought of 6 and 4 because positive 6 times positive 4 is positive 24, and positive 6 plus 4 is 10. So my factorization of part G is 2 times x plus 6 times x plus 4. Two more left. Part H is next. There is no GCF here. They're not all divisible by 3 or anything else for that matter. And I'm going to then use my AC method because I'm dealing with a trinomial where a is greater than 1. So when I multiply a times c, I get negative 60, and my b term that my factors need to add to are negative 11. So we need to look for two numbers that multiply to negative 60 and add to negative 11. Once again, pause the video if you need more time. Otherwise, you should have gotten negative 15 times positive 4 is going to be negative 60. Negative 15 plus 4 is negative 11. So I'm going to open up two parentheses, start each off with 3x, and I'm going to fill in my factors of negative 15 and positive 4. Are one of these divisible by our a term of 3? And the answer is yes. So I divide my first set of parentheses by 3 because both of those terms are divisible by 3. And I'm left with 3x divided by 3 is x. Negative 15 divided by 3 is negative 5 times 3x plus 4. Almost there. We only have one left to go. And in this one, we have 2x squared minus 36x plus 162. We ask ourselves, is there a GCF? And there sure is. They're all divisible by 2. So I'm going to divide 2 out of all of these. And I'll be left with 2x squared divided by 2 is x squared. Negative 36x divided by 2 is negative 18x. And 162 divided by 2 is positive 81. I have a trinomial where a is equal to 1. So I'm going to factor using my rules that say what two numbers multiply to 81 and add to negative 18. I'll start off each set of parentheses with an x because x times x is x squared. And you should have noticed that 9 times 9 will give you an 81, but also negative 9 times negative 9 will give you an 81. So negative 9 plus negative 9 gives you that negative 18 you want in the middle. Our last thing that we could do to simplify this one step further is, since we have two of the exact same factors, I could rewrite that x minus 9 as x minus 9 squared. So we just did 9 exercises where we mixed together all of our methods of factoring. And we used a specific method where we asked, is there a GCF? Is it a difference of two squares? Is our a term equal to 1, or is our a term greater than 1? And we kept using that same method to determine which method of factoring we were going to use to simplify each of these expressions. And if this video was helpful, please give it a thumbs up, and you're now ready for exercise number 2. Thank you for watching.